Hello everyone. Today I'm going to introduce an exciting new technology in computer networking, which is called P4. So to understand what is P4, let us first see how the traditional network routing works. So as you can see in this figure, in traditional networking, we have a router that has a number of interfaces. So when a packet comes through an incoming port, the router decides to forward the packets in one of the available outgoing ports. So how it how it decides which port to forward. For example, here we have the ports 2, 3, or 4. It does so based on uh, the certain fields on the packet header. So basically it looks at this destination IP address, and then which is present in the packet header, and then it matches this routing table where it contains different ports against a number of destination IP addresses. So when it finds a match, so suppose it contain the packet contains 3.3.3.2 10, then it will match this IP address here into here, and then it will see that okay, the next hop will be 3. So this is how traditional routers work. Now then it will be forwarded to this port. So the main problem with this approach are basically that this technology is pretty much fixed. So here the number of bytes in the destination IP address is fixed. So how many hosts it can support is limited by these 4 bytes, and also how it forwards. So it will match the packets, match this destination IP address with this routing table. So this is how it works, and you cannot change this behavior of this data plane, right? So this is the data plane behavior, and how these routing tables are populated is another story, which we call control plane, which I am not going to discuss today. So basically P4 is all about the data plane behavior. So in summary, in traditional routing, this the fields in the packet header and how the data plane forwarding works, the mechanism itself is decided already unchangeable, it's fixed, which can cause limitation for newer protocols, right? So to develop a new protocol, let us say, suppose you think that the number of IP address in traditional IPv4 is not enough. So instead of 4 byte destination IP address, you want to design this IP address maybe 5 bytes. So as we know, IPv6 is available, which has a longer destination IP address, but you may think that this is redundant, and let us go for a 5-byte IP address for this particular segment of the network. And it's not possible with traditional networking. So we also need to change the routing table to have these 5 bytes. So this is just one example. Another example may be what we call source routing. So we'll specify the address of the we specify the address of the the destination address, as the sequence of ports that come along the path. So let's say we want to reach here from this port 1 of this first router to port 2 of the second router. This is our path. So what we can do is we can send a packet and say, well, okay, well, this address is 3.2. So when this first router sees the uh, 3, it will forward to port 3, and then when the second router sees that the port is 2, next port is 2, it is sent to forward port 2. So the path can be embedded inside the packet itself. So this mechanism has its own advantage. So I'm not going to focus on any specific protocol here, but just my what I'm trying to show is these kind of things are not possible with traditional routing, which uh, which uh, which can be very limiting. And this is exactly what P4 is designed for. It allows to design custom protocols like the examples I have discussed just now. So you can define any number of headers, and they can have any sizes, and also how those headers will be processed by the switch or router. For example, here we are using taking this by one the bytes. Maybe it can be even a combination like more than 1 bytes to specify the fast port. It all depends, and then forward accordingly. So these things are possible by the P4 technology, and also P4 is stateful. So one can design, for example, firewall. So it can define variables where it can create and update variables. Suppose if there are too many packets in a certain duration, you want to block subsequent packets, right? So these kind of things are possible by P4. So in the next videos, I will show how to install and get started with P4. But for now, this is all. Thank you.